All right, welcome back to Lag Demon Programming. Just as a reminder, in the last video I talked about the possibility of turning this into a multiplayer game and a server-based thing using multi-threading and networking, and go into some network security stuff, cybersecurity maybe, just to make sure it's a secure server and all that kind of stuff. If you're interested, leave a comment on this video or in the previous video. And I will take a look at those, and if there's enough interest, that's a path we'll go down. And there's other things that we can do too. And if you're interested in going down a particular area, you have an idea, leave a comment. And I'm very open to going in different paths with this program. So let's get down to it and get started. In the previous video, we got the binary and unary expressions set up. Now we need to do the if, then, else, and the function call, and we will have the expression all filled in. So let's do the if, then, else expression next. We'll go over here to our AST. Now an AST is a if, then, else is an expression, but it's not a binary expression or a unary expression. It's a special expression all of its own. So we'll just come down here and we'll go class, and I'm going to call this a trinary expression. And the reason is because we can do some syntactic sugar. It doesn't have to be if, then, else. It's simply a trinary expression. It's got three parts. It's got a condition, it's got a true path, and a false path. That's what a if, then, else really is. It's a trinary expression. So this trinary expression is based on just an expression. And so we will come in here and go protected, and so we have an expression. We'll make that an expression pointer, and it is the condition. So it's going to have to be a binary, or it's going to have to be an expression, a Boolean expression of some kind that produces it. And we're going to be pretty type strict here, so we're not going to allow just numerical values to act like Booleans. We're going to have a special Boolean type. So we also have an expression that is the true expression. And we have an expression that is the false expression. So it's the expressions when the condition is true, we're going to ultimately return the true expression. If the condition is false, we'll return the false expression. And I'll explain that in a little bit more detail, why if, then, else is actually an expression. In the functional paradigm, if, then, else itself is an expression that returns a value, rather than flow control in the normal sense of do a bunch of stuff if it's true, or do a bunch of other stuff if it's false, or just do nothing if there's no else condition. We have to have an else condition because we have to return a value. We have to provide a value of the correct type back. So it's going to simply say, if it's true, follow this, do this expression. If it's false, do that expression. So we have a trinary expression, and it's going to be expression pointer condition, expression pointer true, expression, and expression pointer false. Oops. Expression. So we will do this condition, true expression, false expression, false expression. Okay. We want to go ahead and be able to print this out as something and have our, except for our visitors we will eventually use. And so what we want to do here is we could print this out as if then else, or we could print it out in another form. For now, we'll just print it out as if then else. So we'll go OS from, I'm going to use capitals, if from underscore condition pointer out OS from that condition pointer out OS, and we'll do OS from then and true expression dot pointer out OS, and then OS from else, and then false expression dot out OS. There we go. We have that so far. This. Type it right. Oh, what did we do wrong? Oh, dot. I used a dot somewhere. There we go. So we can come over here to our if then else, and we want to go $$ equals new trinary expression $2 $4 $6. And if we did this right, it should compile, and it doesn't. Expression is inaccessible. Oh, okay. Inaccessible base class means I forgot to put public right here. And we got that far. Okay. And then we have function call. So a function call is also a type of expression. It's going to return a value. So again, we need a class, call it function call public, will be an expression. So what do we need for a function call? Let's go take a look at this here. So fun call is, where is it? Is it up here? Fun call. It can be an ident followed by a unit type. So we have this special unit type down here, which is an open and closed parent. In fact, I could actually probably make this a single token, but we'll leave it that way for now. A function call can be an ident followed by an R value list, or an open parent, or closed in parentheses. A function call closed in parentheses. So how do we look at this? Well, what's an R value list? This is an R value, L value, a statement list, R value. There's the R value list. So to build that up, we need to at least come up with this R value list. Now, an R value can either be a literal value, it can be an identifier, a variable name, but we think of those as values in this. They're just another type of value, or it can be a function call, another function call in that slot for that R value. And that's where it would be something probably enclosed in parentheses in order to group it and say this is one argument in this list. So because a function call is these things, a function call is also an R value. And so we've got up here that that an R value can be an L value, a literal, and it can also be a function call. I forgot to add that one in. This is what R values can be. So it can also be a function call. So we've got to kind of work out how this is going to be accumulated into lists of things that can be R values. So we probably need to work out what our R value and L values are. Well, we kind of know what an L value is. It's an identifier. We did something down here. We got types, we got identifier, and we got a typed identifier. We just call it an identifier. This is just to break it down what it is. So if we go all the way up to here, we know what an identifier is. So we can go up here and make an L value. An L value, by the way, always has to be an identifier because it's got to be a storage location. So we've got identifier already. It's a typed identifier. We can come down here and go %type typed identifier, and that's a L value. An R value, however, is going to have to be this group of other possible things. So it's going to have to be an R value. Can be it can be an L value, it can be a literal, or it can be a function call. Well, you know what an L value is. It's an identifier. We already have a class for that. We need to have something for literals, and we have to have something for function calls. So did we do literal yet? Where's literal come in? Line program, let statement, body statement, L value, R value, literal. Here's a literal. So it can be a literal, can be any of these. So we've got to have some way to have a literal, which is a value of some kind. And we're going to get back the actual value. So we have to have a node for a literal. We have to have a node for a we've already got the L value. So all we really need to do is quickly make this literal, and we will have function call literal and L value. And we can group those all together as some type. So let's see what we did here with identifier, which is L value. So let's go take a look at identifier. It's up here at the top. So one of the first ones we did was we created this identifier, and we called it, said it was based on an FNG node, but really what we need is another in-betweener here, and what we're going to do is call this class L value. No, we're going to call it an R value, public FNG node. And then we're going to have a class L value, and an L value is an R value, but an R value isn't an L value. Okay, isn't necessarily an L value. An L value can sit as an R value. An R value cannot necessarily sit as an L value. And an identifier is an L value. So this should still compile. A little bit of refactoring here. Typed identifier L value, previous declaration. Did I already do that? Typed identifier, typed identifier L value. Type redeclaration for L value. Oh, it's an expression. An an L value is an expression, so is an R value. So we're okay. I've got them as nodes. So actually, we have to move expression node. We have to move this expression node up to right after node. And this has to be an expression. An R value is definitely an expression, and L value is an R value. An L value can be an R value. I think I had that wrong. An expression is a node, that's fine. R value is an expression, and L value is an R value, which is also an expression. And then an identifier is an L value. Let's see if that worked. Missing semicolon? Oh. On our function call. All right. And a function call isn't just an expression, it's an R value. Now really, let's go take a look at this. I said an L value was an expression, but really an L value, what we need to do is have here, we need to have L value pointer, L value, and R value pointer, R value, and percent type L value is an L value, and percent type R value is an R value. I think we'll be okay with that. Yes, it seemed to like that just fine. Okay. So far anyway. I never know about this. So now we've got to take care of our literals. And we know what a literal is. It's always an R value. It has to, you cannot assign something to a literal. A literal is just a literal. It has to be an R value. So we can go back over here to our AST and come up here to where we have our expression R value and identifier. And so a literal, we're going to make a template. And this is going to be a class called a literal, and it's going to be of type R value. Or it's going to be publicly derived. We've got to do public here from R value. Okay, so protected, and we're going to have types, underscore type, and we're going to have T underscore value. Protected. Protected. Oh, what's wrong with you? There it is. Okay. Public. And we will have literal. And we're going to go types, type. And we're going to go T value underscore type, type underscore value, value, and then we want to have a types, get type, and we'll do a return type, and we're going to have T get value. This is a literal, so we can't ever set the value. Once it is known, it is known. We'll return underscore value. And there's an object for all of our types, and it's based on our value. So we can go back over to here. Now it's our value, and a literal has to be an R value. So up here under types where we had R value, we need to put literal in there. And this is a convenient thing because it's a literal, or it's an R value, which our template is. So any object we create is an R value. So actually we can move this type and value thing to, actually we should move that to our an L value has to have an identifier. We'll come back to that, because an identifier, we could move this and type and value to our value. We'll refactor that later. This is fine for now. VALUE. What I got wrong? List or what? Literal. Literal. Something else wrong. Redefinition of literal. Did I do literal already? I don't remember doing. Class literal. No. Redefinition of class literal T. Oh, it's in our command processor. We use literal, and these ASTs are getting mixed up. So what I will do then is, rather than messing with namespaces right now, we'll just call this an FNG literal. That'll be fine, just to separate them. We should organize these into namespaces, I guess, and we wouldn't have those name collisions, so it compiles. So now we have back over here, we already have the R that, so we know that a literal is that type. So what we can do here is just start filling these in. We can say that $$ equals new FNG literal, and it's going to be types : string, comma, $1. And let's just make that make sure that compiles. Doesn't like it. Oh, yeah, template type. This has to be a standard string, comma, standard string. That's it. We're sitting at 25 minutes. literal type value. Oh, it's got to be, we've got to dereference it. It's a pointer to a string that we get back from our lexer. Invalid new expression of abstract class. Okay, yeah, forgot to do a couple things. We need we need this, and we need to throw this here under literal, and we don't want this. What we want to do is go OS from, we'll do this really simple, we'll do this, we'll go type to string underscore type, underscore value. And I liked it. Okay, so we're cruising along. And real quick, we're at 27 minutes. I'm going to run down here. I'm going to see if I can paste these in and change the types real quick. And we'll have our literal fixed, and we'll have just about pulled everything together. This is a types : int. Types : int val or int. Let's double check this. What are our types? I'm confused. Types : yeah, it should just be int. Types : float. Char. And bool. And we're going to add some additional types into here, some special types that we will need to build up other stuff, but we won't do that just yet. We want to get this basic stuff working first. Something didn't like something. Oh, because this isn't now it's not a string. These are just numbers. These are just values. Okay. And what didn't it like? Bool val. Bool. Oh. Okay. It's late. I'm getting tired. This is going to be an int. This is going to be a double. We're going to handle doubles in this system. This will be char, and this one here will be bool, and that takes care of all those functions, I think. And it builds. Let's see if it runs. My typos here, I got to get through them. There we go. It runs without failing. So there we go. We're cruising along. We're almost there. We got to get this R value fixed up and the function call fixed up, and then we'll be able to rip right through the rest of this stuff. It's pretty simple. Let statement will have to build out, but the rest of this is just lists and stuff and specific things and transferring data around, and we'll have it. In the next video, though, we're sitting at 29 minutes, so thanks for watching. Remember to leave me comments down there if you have any ideas of what you'd like to do, or if you'd like to make this a multi-user game and set up on a server. One of the things I can do, I have a server, so we get this thing working as a server-based game. I could invite you guys to come on and play around with it on the server and chat with each other and try some things out and get some feel for it. So we can do all kinds of things. If you have other ideas where you want it to go, let me know. I'm open to all kinds of suggestions, so we'll see what we can do and what we have time for. That's it for this video. Thanks for watching. I hope you liked it. If you liked this video, hit that like button. If you really liked it, hit that subscribe. I really appreciate subscriptions. We have over 300 subscribers right now, and we're growing. Let's grow it fast. It really helps me out a lot, and I want to keep producing these videos. So go ahead and subscribe. And if you want to get notifications when I upload videos, hit that notify button. Thanks, and I will see you in the next video.